Word problems are often a sticking point with a lot of people in a math class, and probably the greatest piece of advice that I can think of is to look for, when you have a word problem, look for something that relates your variables, an actual statement in the problem that relates your variables, and then take that statement and translate it into an equation. This requires generally, oftentimes, using variables for some things or figuring out how to represent other things with numbers. Let's just do an example here, though. So I said the horsepower required to overcome vehicle air resistance is equal to the cube of the vehicle speed in miles per hour multiplied by the frontal area in square feet divided by 150,000. This is a really weird problem to do as a word problem because it's literally just telling you the equation. It looks kind of complicated, though, because writing things out in English versus writing it as an equation using algebra, it's a lot harder to write it out in English. This is why we don't like, this is why we use equations and why algebra is so nice. So in any case, the horsepower required to overcome vehicle air resistance. This is all one number. So this big long expression here, we would just call P, for instance, in this case. Whenever you see the word is, it's generally going to be an equal sign. So this number is something. So far we've read P equals. All right, reading this, or I guess is or is equal to. In this case, we actually have is equal to. The next number I see here is the cube of the vehicle speed in miles per hour. This is another number. The cube of the vehicle speed in miles per hour. We're going to use v for velocity and v cubed to represent the cube of the vehicle speed, raised to the third power. We call those cubes. All right, multiplied by the frontal area in square feet. So that's another number here. The frontal area in square feet. So the frontal area in square feet in this problem, we're calling that A. And then it says divided by 150,000. And you can see that's just a number. So this equation right here, this formula right here, is exactly the one that's expressed in this in words up above. All right, now if we wanted to use this formula, we could figure out what is the maximum speed that can be achieved by a vehicle with 123 horsepower and a frontal area of 30 square feet. All right, so I'm just going to plug in the numbers that we need. What was the maximum speed? Yeah, okay, so the numbers we're given the horsepower, 123 equals v cubed times A, that's 30, divided by 150,000. If I want to solve this, 150,000, not 15,000, if I want to solve this for v cubed, this is probably a little bit beyond what your skill should be at this point, but whatever, I'm going to do it anyway. This number, v, is first cubed, then it's multiplied by 30, then it's divided by 150,000. And after you do all that, you get 123. So if you're trying to undo this in reverse order, this is the exact stuff that we've been doing, I would first multiply both sides by 150,000. So I take 123 times 150,000 equals v cubed times 30. All right, next up, and I'm holding off on plugging this into the calculator because it doesn't really need to be. I'm just going to write 123 times 150,000. I don't need to know exactly what number that is. My next step, since I'm cubing this number and then multiplying by 30, if I'm solving for it, I want to get rid of the 30. So I'll divide both sides by 30. So far on the left-hand side, I have 123 times 150,000 divided by 30. And on the right-hand side, I have v cubed. So this is the part that you wouldn't necessarily know how to do at this point. What number, when cubed, is equal to this other number? Well, we have seen square roots. That's answering the question what number, when squared, gives this other thing. There's also something called a cube root, and how we generally write that is with it looks like a square root, but it has a 3 up here. But that's answering the question what number, when cubed, gives us this number. So the cube root of 123 times 150,000 over 30 is equal to v. And this is something I can just ask my calculator. I didn't need to really do the intermediate steps. So on my calculator, I can do cube roots on here. Yeah, I think that's the only way to do cube roots on here. A lot of calculators actually allow you to do cube roots. I'm going to do this in a slightly, well, I'm going to take this stuff and raise it to the 1/3 power. That's a way to do a cube root. You don't really need to know that. That's why I say this a little above what you can do, but whatever. The general process should be hopefully familiar. 123 times 150,000 divided by 30. That's the stuff inside the cube root. And I want to raise that to the power of 1/3. That's taking my cube root, and that gives me 85.04. So if you have a vehicle that has a frontal, according to this formula, a frontal area of 30 square feet, and it has 123 horsepower, the theoretical maximum speed that vehicle could achieve would be 85 miles an hour. All right. In any case, there's all sorts of different, when we're translating statements into equations, there's all sorts of different numbers or all sorts of different words that we can use. I'm pulling this up so you can just kind of look through it. I'll point out some that tend to get people. First off, let's see, subtraction. When you're talking about subtraction, if you say 3, well, let's use variables here. Actually, I guess I have it written right here. If you say a less b or a minus b, those mean this. This is a minus b in that order, specifically in that order. One of the tricky things about subtraction, though, or the tricky things about English, really, is that if you add this word than, if you say b less than a, then the meaning there actually switches around. B less than a is actually a minus b. It's kind of swapping the word order there. And if you need some convincing there, just think of, I don't know, 3 less than 10. If I say 3 less than 10, this means 10 minus 3. It swaps the word order there. We're taking this number away from this one. So we're starting with a 10, subtracting 3. We see a similar thing when you say subtracted from. If I said 3 subtracted from 10, that would also mean to swap the word order. Other than that, in general, we keep the word order, we keep the number order the same. The first number minus the second one. It's only when you say less than or subtracted from, those are really the only cases where you swap the order there. And that tends to get a lot of people. With division, keep in mind that the order of the numbers matters again. A divided by B, that's the standard way you would actually read it. You could say the quotient of A and B. That would also be A divided by B. However, if you say B divided into A, that would also be A divided by B. Dividing into instead of dividing by is one of the ways that you would use in English to swap the order of those numbers. So there's a couple other things on here. I don't know if it's really worth a whole lot to go through all of these. With addition, the order, with addition, the order of the numbers doesn't matter, so I'm not really putting any emphasis on there, saying, more than or less, more than rather. I don't really care if it's A plus B or B plus A. Same thing with multiplication. The order doesn't matter. If it's A times B or B times A, those are equal to each other, so it's not really that important. But yeah, those are some general words that we use when we're translating into equations.